Euler's criterion, let p be a odd prime and greatest common divisor of a and p is equal to 1, then a is a quadratic residues of p if and only if a raised to power p minus 1 upon 2 is congruent to 1 modulo p. The proof supposes that a is a quadratic residue of modulo p, then x square is congruent to a modulo p has a solution x, which implies x1 square is congruent to a modulo p equation 1, which implies greatest common divisor of x1 and p equals to 1. Therefore, by Fermat's theorem, x1 raised to a p minus 1 is congruent to 1 modulo p equation 2. Hence a raised to power p minus 1 upon 2 congruent to x1 square raised to power p minus 1 upon 2 by 1 congruent to x1 raised to power p minus 1, 2 से 2 कैंसिल हो जाएगा, मोडुलो p congruent to 1 modulo p by 2. Conversely, let a raised to power p minus 1 upon 2 congruent to 1 modulo p. If r is a primitive root of modulo p, then 1 r and r squared so on r raised to power p minus 1 form a reduced residue system modulo p, and a is congruent to r raised to power k modulo p for some integer k. 1 is less than equal to of k is less than equal to of p minus 2. Now 1 congruent to a raised to power p minus 1 upon 2 congruent to r raised to power k raised to power p minus 1 upon 2 is congruent to r raised to power k into p minus 1 upon 2 modulo p. Since r is a primitive root of modulo p, r has exponent p minus 1 modulo p, which implies p minus 1 divides k into p minus 1 upon 2. So k must be an even integer, say k equals to 2t. So a congruent to r raised to power 2t modulo p, which implies r raised to power t is a solution of x square congruent to a modulo p.